All right, guys, so we're going to go ahead and do a real life example here. I like this example because within your lifetime, you've actually seen on the news about this down Malaysia airline a couple years ago. And it would have been in your time frame, in your wheelhouse where you'd be able to remember this. So the problem reads, a hiker was last seen at a hiker who was last seen at a visitor center in the national park has been reported missing. A search and rescue SAR team estimates that the hiker would have been walking at a rate of 2 miles per hour. The SAR team needs to determine the possible search area in which to look for the hiker. Number one, the very first part of this. The theoretical search area is circular. Write an equation of a function f of x that gives the number of square miles in the search area when the radius is x miles. Well, my keywords here is area and circular. Well, I know that the formula for an area of a circle is going to be pi r squared. But in the problem, it says my radius is x is in miles. So I can write my formula as f of x equals pi x squared. And of course, my units in miles is also squared. So that's my f of x formula. The second problem we have down here, the second part of this is, it says write an equation of a function g of x that gives the distance in miles the hiker could have walked in x hours at a rate of 2 miles per hour. Well, right off the top of my head, I immediately see that this is going to be distance equals rate times time. But they want my time as in x for hours. And then, of course, my rate is the 2 miles per hour. So my formula is going to be g of x equals my rate, which is 2 miles per hour, times my x, which is my time in terms of hours. Now, the real thing on this is really the number 3, which I didn't bring over with us. But really what it asks you to do is it asks you to do a composition. It asks you to do f compose g of x from these two formulas that we actually have. Of course, f compose g of x is nothing more than f of g of x, which is f of, my g of x is 2x. And of course, then I just plug that in where I get pi times 2x squared. The square goes to everything inside the parentheses, so I end up with 4 pi x squared. Now, of course, this is my f compose g of x. This part here is going to be the result. Your output is going to be your search area. And your x here is time missing. And then the other part of this question, it asks for a reasonable domain. Now, in terms of this question, the reasonable part is the hard part for you guys. Because if you just look at 4 pi x squared and I ask you for a domain, you're going to say all real numbers. Which I agree, mathematically, that would be the domain because there's no restriction on this. However, in terms of this question, we can eliminate any negative numbers unless you have a time machine because time is always moving forward. We can also eliminate 0 because 0 itself, you haven't been lost at zero time. So the way I would look at this domain would be the set of all x's such that x is an element of a real number because they can't be lost on every hour increments. They could be a tenth of an hour, a fifth of an hour. You can go down to like hundredths of a second. But you do have to put a restriction. And I want to say x is going to be greater than or equal to 0, but I'm not going to do the greater than or equal to, so I'm going to go ahead and erase that. It's just going to be greater than 0. And the reason why I'd be okay with this, because I'm a parent. If my daughter went missing, I would never stop looking for her, so I would consider that infinity. So this, I would say, is from 0 to infinity. But the key to this is you have to justify this. I could say that x must be greater than 0 because at time 0, he is not lost, and infinity because someone is always looking for him. Now, you could have said, hey, X has got to be greater than 24, saying, hey, I'm not going to report somebody missing until it's a day. That makes sense. It's reasonable. Reasonable can be different things for different people. I know when I've gone to parks, we plan on spending 4 to 5 hours there. So if I tell somebody, hey, we're going to be at this so-called park, let's just say Bandelier National Park, and we're going to spend, let's say, the day. The day to me is 8 hours. So if somebody is looking for me during that time, is oh, well, he's at the national park. But if a day goes by, then all of a sudden they're like, wait a minute. Or even at 9 hours, if they're expecting me back, they're like, hey, wait a minute. He said it's only going to be 8 hours. Now I'm concerned. Let me call and see where he's at and report him missing if he has to. But you have to be able to justify the whole part of the reasonable for the domain. This is kind of important to know. This is a classic type of example that you will see multiple times throughout math.